Well, good afternoon, everyone. Welcome to the Lunch and Learn hosted by Wavelogix. My name is Suzanne Florick, and I'll be your host today. We're thrilled to have you join us for this insightful section on integrating Rebel sensors for smarter construction in a conversation between Steve Fries and Joe Turek. Before we dive in, let me review a few housekeeping items to ensure you have the best experience today. This webinar is being recorded, and a copy of the recording and any presentation materials will be shared with you via email afterward. For the best viewing experience, we recommend using the gallery view speaker view. You can switch between views in the upper right-hand corner of your Zoom window. Please use the Q&A feature at the bottom of your screen to submit any questions you may have during the session. We'll address them during the Q&A portion at the end of our webinar. If you encounter any technical issues, let us know, and one of our support team will attempt to assist you. Now, it's my pleasure to introduce you to Wavelogix and our distinguished speakers for today. Wavelogix was founded in 2021 in partnership with INDOT and Purdue University to improve road and bridge reliability while reducing traffic disruptions. The Rebel concrete strength sensing system provides real-time, in-place measurements of concrete properties, offering a more precise and versatile solution than traditional sensors. With our patented technology, Wavelogix eliminates the need for preset maturity curves, delivering accurate results across various projects and helping teams optimize schedules and reduce costs. Joe Turek is the president and COO at Wavelogix. Joe received a bachelor's degree in electrical engineering from the University of Notre Dame and an MBA from Northwestern's Kellogg School of Management. He's been involved in manufacturing his entire career. He holds 5 patents involving high-performance microwave telecommunication circuit board technologies, and he is a registered professional engineer and a member of IEEE. Steve Fries is Vice President of Concrete Operations at Milestone Contractors, LP. Bringing over 40 years of experience in heavy highway construction, he has led more than $750 million in projects across both public and private sectors, with expertise in estimating, budgeting, scheduling, and team leadership. Steve is known for driving profitability, delivering high-quality results on complex interstate projects, and building strong relationships across all stakeholders. His work has earned numerous honors, including multiple ACPA paving awards and the America's Transportation Award. In 2023, he served as chairman of the National ACPA Board. Please join me in welcoming Steve Fries. Joe, I'll turn it over to you and enjoy your conversation with Steve.
Fantastic. Thanks, Suzanne. Steve, we are really thrilled to have you on board today in this series of webinars. You are a well-known figurehead in the industry. Those that don't know you don't deserve to be in the industry, right? That's really great. Just to get things kicked off, for those who aren't totally familiar with what you're doing today, most people think you're just relaxing on a beach somewhere in Florida. Can you kind of give us an overview about what you've been up to lately with Milestone and your life?
Okay. First of all, thank you for inviting me. All those nice things you said about me. My wife just shakes her head and says, "I'm going to have to put a bigger door in the front door to get your head in and out of there." But thank you very much. I appreciate that. Currently, I'm no longer vice president of concrete operations. I'm now. They gave me a new title. I think it's called concrete personnel manager, which allowed them to reduce my hours and reduce a few other things so that we're all happy. But I'm still pretty much doing everything I did before. I'm still currently the president of the Indiana ACPA, and I am still on the board for the ACPA Foundation, which is a foundation that we put together to prolong concrete and concrete learning, helping emerging leaders and helping other projects to spur on new innovations in in concrete and concrete technology. And
Oh,
yes,
that's
I'm not on a beach, but I'm close.
stop making us jealous. Uh, you've you've been in the industry for a long time. You've seen a lot of innovation. How have you seen innovation integrated into great companies like Milestone?
Well, when we were talking a little earlier, I started out with concrete form paving, and that was a long time ago. And I don't even know if anybody even has form pavers that ride on rails anymore. But I've seen it go from that to slip forming with string, and now to stringless. And now finally, we're getting around to getting some testing that is not 100 years old. I'm really excited about some of the things. One of the things is this Rebel sensor. Uh, Very excited about the opportunities it gives us to do a whole lot of things out in the field that we weren't able to do before.
Yeah. Speaking about Rebel, interesting that you bring that up. How have you seen the Rebel potentially enhancing, concrete, the construction process with concrete, and how has it maybe been integrated in with Milestone?
Well, it says it started in 2021.
Yeah.
I'm thinking back around 2016, 2017. I had the first generations of the Rebel sensors out on a couple of my jobs. I got a call from Luna, and she said, "Hey, we got this new thing we want to try." Well, Milestone's relationship with Purdue has always been outstanding from the days of Jason Weist all the way to now with Jan Oleg. We've always had a great relationship. Then we had a guy here who was named Dick Newell, who some of the stone companies named stone after him because he insisted on clean material. So they called it Dick Newell stone. So I got to give a plug for him because he started our relationship with Purdue, and anytime Purdue came up with anything, I was more than happy to give it a try out on our projects because we had that ability to do that. Um, I've seen this go from a big, huge box on the side of the thing down to this tiny little thing that they have now. It's been phenomenal, and I don't know. You ask me some more questions about it, and I'll tell you what I really love about it.
Well, that's a good segue. I mean, what do you think about it potentially reducing project delays? Kind of let's talk about how it might be used in its application.
Well, we've been fortunate enough in Indiana to get it to be accepting. It's now used for acceptance to opening to traffic, which is phenomenal. First of all, the fact that you don't have to do a maturity curve to use it is spectacular. So you cut down on a whole bunch of lab expense to begin with, and then next thing you have a sensor out there that starts to read it and gives you real time uh, maturity on your concrete and when you can open it. So now instead of waiting to break a beam at some specific 2 or 3 day, or sometimes depending on how hyped up the mix is, maybe in 18 or 20 hours. Now you're just waiting for the meter to come up, and once it hits, you can open the traffic. That is spectacular. But that's just the beginning.
Yeah, so you certainly have highlighted, one of the benefits of the Rebel sensor. It's real time, so it gives you data with all the time. You don't have to wait for beam breaks. And as I understand, Indiana was kind of famous for being one of the last states to actually continue to do beam breaks on their pavement, right? Almost everyone else is using compression brakes.
Them and the FAA.
And the FAA, okay. So, and we also kind of know with some of the new low carbon concretes, even like 1L, it gets even more difficult with the flexural strength of those beams not coming up to strength a lot, in monitoring those. I think we've seen those as a problem in the industry. At the same time, you uh, the data is real time compared to maturity sensors, where you have to kind of calibrate it to every one of the mixes. Do you find that kind of a benefit when you don't have to do calibration?
Absolutely. Just that, not having to do a maturity curve, uh, you know, saves anywhere from 500 to $1,000 a mix.
Yeah.
And with the latest shortages of materials, when you have to change mix designs, there's nothing like waiting and doing another maturity curve that takes, you know, a week or 3 to 5 to 7 days to do. So that now you can just go out there, put the sensor in, it tells you when it's done. That you just can't get any better than that. Plus, on top of that, you don't have to worry about how the beams get handled, because in this labor shortage uh, era that we're in right now, when it comes to this labor, and I'll be honest with you, I never enjoyed carrying beams around either. They're quite heavy, and a lot of times they don't get treated with the kindness. Every time I look at a beam, I look at it like it could be anywhere between 20 and $50,000. So I handle them a lot differently than the guy who's testing them, who throws it in the back of the pickup truck and says, "Oh, I'll ride around for about a day and a half, then I'm going to take them to the lab." So, and I know those are two extremes, but somewhere in the middle is the truth, and it's scary that the beams just don't get handled like they used to get handled.
Yeah.
So to eliminate them is big, big, big for every contractor that's had to deal with them.
Yeah. That's really great. Well, it's there's a major project going on right now in Indiana. There's a large paving program that I think Milestone actually won that project with, that will be implementing our sensors. I think it's maybe 26 miles of roadway, and I think it's going to use over 100 sensors in that, about 10 sensors per mile. So it's I think that's really going to highlight maybe how the use of that sensor is in a real life production project. It'll probably be one of the largest ones that we have done to date. And I give high marks to Indiana and to Milestone for moving that technology forward. Are you involved in that project at all?
Yep. Yes, I am. I kind of on a 20,000 foot level, but I've already been with our head of our lab, Devin Odell, who, by the way, runs a really nice ARM or ARL CCRL lab. Uh, Milestone happens to be the only contractor in Indiana that has that level of a lab.
Mm.
And Devin does outstanding work. I'm looking forward to using those sensors. I'm looking forward, and believe it or not, the one of the hidden things about using these sensors is that right now when we do our, we've done thermocouples, we've done beam breaks, we've done all the different things. Once you get that break, you pretty much throw everything away and don't think about it anymore. Using these sensors, we can leave them in for 28 days, or 30 days, 60 days, 90 days, and see how much we're over designing all these mixes. And everybody wants to talk about sustainability. You want to lower the cement content. Find out that you're putting way too much cement in, uh, at 30 days and 60 days. And then you can really start talking about a sustainable mix that uses less cement. And right now, we don't know that because we throw all the information out and don't look at it again. These
Yeah.
sensors have the ability to, I don't know, stay as long as we want, I think, right?
Right,
Years.
right. That's yeah.
I
So they're relatively inert. The nice thing is our sensor works on wave technology. It's not working on a thermocouple like maturity sensors work on, and um, and so a maturity sensor is really only as good as you have heat in the reaction, and after about 24 hours, the heat starts slowing down, and then everything after that is just cooling down, and you end up with environmental temperature, and it's really a combination of time to estimate what the strength is. Our sensors can stay in the ground and you plug back into them a year later if you wanted to, and you can take a reading and you can actually see what the strength is of the concrete. And as we know, concrete virtually never stops curing. It just gets stronger and stronger as it goes on. The I was just at the NCC meeting this week in Chicago, and again they brought up the fact that with low carbon types of concrete, 1L type concrete, they're looking at trying to go to 56-day readings as opposed to 28-day, because they're not getting the total cure that they are looking for at 28 days, going up to 56 days. But the other thrust of that, as you kind of just brought up, is kind of interesting, I think, is that if you can go 56 days and it takes a little bit longer to cure, it really gives you the ability to lower the amount of cement in concrete. And Dr. Luna Liu has been talking about over cementing in the industry by 20 to 25%. And the number that they used at the NCC conference was that they said it was closer to 50% over cementing. And that there's a great ability to start to reduce the amount of cement in concrete. So I thought that was kind of an interesting thought, and definitely having a sensor that can go the distance works out pretty well.
No, I definitely concur with that. I think we put way too much cement in all these mixes, but hopefully this will be a gateway to start to remove some of that extra cost and expense.
Yeah, for sure. What are the other things? Are there any ways that you can see the sensor being used that would reduce the overall cost of a project? I mean, are there efficiencies by having real-time data on strength?
Absolutely. Just knowing when you can make a traffic change sooner, based on these sensors, and having real-time information where, when here you can see the brakes coming up, and once they're used more and more, you'll have a better feel for all your mixes, based on the weather, based on on what's coming in, what fronts are coming in and out. You'll get a good feel for how fast your mixes are really curing and how
Mhm.
fast you can open them up to traffic. So that's a huge uh, expense savings. Second
Mhm.
one is the number of people you'll have to have out there to make the beams, cure the beams, take the beams, bounce the beams on the way to the lab, you know, and then break the beams. And
Yeah.
then when the beams don't break right because they weren't handled right, you'll have to go back and core and then do a split tensile. So it'll save all kinds of money and time in that respect. And
Yeah.
I unfortunately we probably have to do that. I don't know, maybe 5 jobs a year where
Mhm.
we have to go back and core the pavement and do a split tensile because the beams haven't been handled correctly. However, our sister beams show that they have been.
Mhm.
So, it's just a
Yeah.
matter of, I think the state would feel a lot better about, or the DOTs would feel a lot better about how things are being handled.
Yeah, but I mean, it's 100-year-old technology of using beam brakes and cylinder brakes to measure something, and I think it's great. Maturity was a great improvement, but it just didn't go the distance. Our sensors plug into a data logger that then communicate immediately up to the web via a cellular phone or a cellular radio inside the data logger, which we think is kind of convenient, especially if you're doing a paving project and you have 10 sensors for every mile. With maturity, you have to usually go back and collect the data, manually. And to have someone again running down the road for a mile collecting 10 data points doesn't sound very efficient. Sitting at your desk or sitting on the beach somewhere and looking at the data, on your phone is I think a much more efficient method for measuring the strength.
I
The
wouldn't use the sitting on the beach as a good it sounds great, but you still got to be there.
Or you're just
That was
inspecting the sand for the project, right?
Yes, exactly. You're getting gradation tests.
that was an
Yeah.
outside the box work from home.
Yeah, that was really working from home there.
Uh, so what kind of advice might you be able to give to, construction industry and others, with adopting new technologies and specifically revolving around, the new methodology for measuring strength? How do we get people to both know about it and adopt it, try it out? What are your thoughts? A Milestone has always been very innovative and been a leader in trying out new technologies, but a lot of people kind of drag their heels in doing that.
Well, we we love new technology. Some of it works out really good. Some of it doesn't work out so good. We try a lot of it. Our Heritage Group, which is our parent company, has a innovation council that goes after all kinds of innovations in the road paving and a lot of other industries. Uh, for me, with these sensors, I got no issue at all at running side by sides. Run some beams, which is what we've been doing here lately. Run some beams, run these sensors,
Mhm.
compare the results, compare the results with everything, and then compare your costs to do each one of them, and keep accurate records about what it costs you to make your maturity curve, what it costs you to make your beams, what it costs you to check the beams. Then you got to get rid of the beams. Keep all those costs, and then see what it is against the sensor that you're putting in that's uploading to the cloud. And even the other ones, even the other sensors that are out there, compare your costs, because right now this is the only one that I'm aware of that you don't have to run a maturity curve for. To
Right.
me, you keep all those costs and write them all down, you'll be able, numbers don't lie. It'll come up with the way, and you'll see the right way to go. and
Mhm.
and to get the state to accept them, we were on a program right now where they basically told us, you use these things, show us that we're getting consistent results, and we'll approve it. We have it approved right now for in Indiana for opening the traffic, which is a start. It's a good start. We'll give them more data this year. Obviously, that job that we have down there, going to have a ton of them on there, so they'll be able to get lots of information, and hopefully they'll act on that information in a quick manner.
Yeah, that's I appreciate that, and I think that's good advice. A lot of times we talk to folks about how we really believe this saves money, and they're like, oh, it doesn't cost us anything. It costs us $25 for a beam break. It's like you're not accounting for the time, the energy, the amount of material, and all the other things. So yeah, that's a good perspective that
And
you
and then
really
to
have to
keep
look at the whole picture, right?
and then keep track of the fact that your sister samples all break at a passing rate, but the DOT's doesn't break at a passing rate. And you
Yeah.
sample like they were bad beams, so then you get to do the cost of coring the pavement and splint tensile, and then they do it, and then they say, oh geez, everything's okay. Here's a bill
Yeah.
for $2,500 because we had to do that
Right, right.
because we
It's
didn't take care of the beams the right way. And I hate to say it that way, but it's true. And I was quite amazed when talking with the FAA, because we just finished two big airport jobs, and they said on projects in the United States they have a lot of misuse or mishandling of the beams there. Now we didn't have that on our job. We were very fortunate that we everything passed flying colors, but they said there's other jobs that happens on. So they are actually, my understanding is that the FAA and even Tri Services is starting to look into alternative methods of pavement acceptance. That's the best way I can. There's a committee out there right now that's doing that. So
that's looking at
we'll
that.
be we'll be excited to have some input to that and see what it brings on.
Yeah, no, that's great. Um, our product, I should mention, not only we've been talking about paving, but it's also used in bridge work, used in patching for very fast accelerated curing, higher strength concrete as well. We're working right now with some applications on UHPC. So great stuff there. Vertical applications, building structures, columns, beams, and then the precast world. Great opportunity there with precast and pre-stress as well on the beams. Everyone's always all about speed, right, and getting real-time data. Uh, we're also working with the ready mix industry that as a QC tool to help them prove that what they deliver to the job site is accurate, and that if there were problems with placement, that it may not be their issue. And then we're starting to work with test houses that actually allow third parties that do the cylinder breaks and beam breaks for the contractors to actually help them integrate in the technology as well. We were just talking with one test house, and he said that he was asked the question, well, isn't that kind of putting you out of business because you're not going to be able to do more breaks if you have the sensors there? And he had a really great comment. He said, you know what? I lose projects because I can't get out to the site and have all these people out there making the cylinders and monitoring this, that if I had a sensor that I could deploy easy enough, I don't have to have these teams out there. I'm going to win more business where I can't compete against some of the bigger guys that have huge crews. I thought that was a great perspective on how to use technology to your advantage. It's sort of like we're going to make the manufacturing more efficient, but we're not trying to eliminate jobs. We're trying to be able to do more with what we do have. We know how hard labor is today to get. I hear this all the time. I just can't find good qualified people to do the jobs. So if you can get technology and use that to be more efficient, then away we go. I know also we collect our data, and the fact that it gets shown on a dashboard gives you the ability, many people, to actually be looking at the data at the same time. And it's got to be frustrating, Steve, if you're on a project and you're waiting for someone to give you the results of your cylinder break, or get a cylinder break that you need at 2 a.m. in the morning, and you can't get anyone out there to get it, right?
That's how I got a couple of these gray hairs, worrying about stuff like that.
Yeah,
Worrying
yeah,
about stuff like
absolutely.
that. And oh yeah, we opened the traffic, 8 hours ago. Well, it'd been nice if you told me so I could have slept last night, but
Yeah, absolutely. So that all those things I think are kind of exciting with this technology. Um, Sue, do we have any questions at all from the field?
We do. We do.
Okay, why don't we open it up to some of those for Steve?
I've got a couple here. So one is, how is the durability of the sensors in multiple freeze-thaw cycles after casting concrete if you wanted to monitor a structure for years? If placed in a bridge deck in a northern climate like Vermont, they would experience many freeze-thaw cycles per year. How do they react to that?
Yeah, yeah, I'll take this one, Steve.
yeah, yeah. I just put down I'm in Florida.
Yeah, there's no freeze thaw down there, right? We
Yes.
only have salt
Well,
water to deal
once in a
with down
while.
there.
Well, it could be opposite, mega heat, right?
That's right.
Hmm.
Mega heat or a lot of salt, a lot of salt. Um, Fun fact, I was talking to Florida DOT and they told me, here's a fun fact for you. You're no more than 60 miles from any ocean front in Florida. I thought, well, that's kind of interesting. So you're going to deal with a lot of salt water. That's a really good question. Our sensor holds up well over time, being embedded in the concrete. It does have a cable that comes out, and that cable gets plugged into the data logger. You can unplug the data logger and come back and plug in a year later, and you could take a reading and it'll automatically populate the dashboard. The trick is that you have to maintain the integrity of the cord and the plug over a period of time. So having it just flopping around in the environment isn't very efficient. Some of our contractors have talked about putting it into a watertight box off to the side of the structure, and then have access to come back and unscrew it or open up the box and then take a reading and then go from there. I will just to talk about the technology. Our sensor is 4 inches. Let's see if the camera picks this up. 4 inches in diameter by about a half an inch thick, so it's relatively thin. But its localized area that we're measuring is only about a 4 inch cloud around that sensor. So if you're trying to look at the degradation of a structure, you would want to assume then that that structure is degrading the same across the entire structure. We're not scanning the whole structure. We're not scanning a large area. We're looking at 4 inches. So it is very possible that a bridge could be cracking or decaying in a totally different spot from where our sensor is located. And so you're going to get an erroneous result. We just don't have our product out into the marketplace long enough to really be able to show results of durability and how the concrete might be decaying. But theoretically, if the structure around 4 inches around the sensor starts to decay, I will guarantee we will pick that up in our sensor readings.
Okay, thanks, Joe. I got a couple more here. The sensors have temperature recording capability, correct? Yes.
Correct.
What is the minimum maximum temperature they can handle?
I think we can go, there's probably no minimum. I mean, we're not measuring on the moon, but I would say in practicality, in the environment where concrete would be poured, we can certainly go negative if needed. Our upper end of the range is about 185 degrees to 170 degrees Fahrenheit. So much hotter than that, we would probably have an issue. That's what our sensor is rated for. Even though the thermocouple can measure greater temperature. We have a thermocouple in our sensor and in our data logger, which is outside of the structure. So the sensor to be in the structure, the data logger outside. And so on the dashboard, you'll see 2 temperature measurements inside the structure, outside the structure. It's a great mechanism for contractors to understand what's happening in the environment, as well as what's happening in their structure. And if you're in a really cold day, you can see that. And if you need to heat the structure like a bridge, you have the ability to do that and see the immediate net effects. You could absolutely use our sensor as a maturity sensor. If you had a maturity chart already, our thermocouple shows that it measures within a half a degree of what a maturity sensor's thermocouple would measure.
So Joe, backing up on that question a bit, one additional question was, do the sensors and data loggers handle the heat and moisture if accelerated by the use of steam for curing?
For steam for curing, that's a good question. Steam is what, 212 degrees Fahrenheit. If the sensor was directly in steam, I don't think the structure itself would get up to that temperature. I wouldn't recommend having the data logger in a steam bath. It would be off to the side. But typically, when you're using steam to heat concrete, the concrete isn't going to get up to 212 degrees. If it did, we would probably have a problem with our sensor. But certainly the sensor, stays inert. It's basically rubber and epoxy, and it can take a lot of heat. It can take pressure really well also. So if you put it into a deep well, it would take the pressure of the concrete there. We've measured the pressures on our sensor up to over 5,000 PSI in terms of compressive strength without damage.
Okay.
I hope that answered that question.
So do you have a recommendation for how many sensors or where to put them for bridge elements and decks?
Yeah, we typically say, 1 sensor for every set of cylinder breaks that you would normally do. So whatever your spec is for cylinder breaks, if you did a set of cylinder breaks, if you did 3 of them for a bridge, or if you did, multiple ones, we would recommend the same. However, industry, kind of looks at ways of doing this. We always recommend more than 1 sensor in a critical structure. So like a bridge, you'd love to see 1 at the beginning, 1 at the end, maybe 1 in the middle, depending on the length of the bridge, per lane or per pour of that day. If you were doing a different pour, you'd put that in. We typically target about 9 to 10 sensors in a bridge project. We typically target 9 to 10 sensors for every mile that's poured in a continuous fashion. So if you're pouring a mile 2 lanes wide, you'd use 10 sensors. If you were pouring only 10 feet wide for a lane, you'd still use 10 sensors over that mile. So it's kind of based on pouring in that. If you were doing patchwork, you'd put one sensor in the patch. I wouldn't recommend having two. That would be less critical, but I wouldn't go crazy with, you don't have to add a sensor every foot or so. It's a practical tool used to understand how the homogeneity of the concrete might change. And for the most part, it's pretty homogeneous from batch to batch on the same day.
Okay, I got a couple more questions here. Does the Rebel sensor directly measure or calculate the modulus of rupture from the compressive strength? And what thickness of concrete is measured for compressive strength and modulus rupture above or below the sensor?
So we're per the T412 specification, the actual specification that our sensor falls under, we're required to deliver to the end user 3 data points: modulus, compressive strength, and flexural strength. And so those are all accessible. And in the future, in the near future, on our data, on our page, you'll be able to click between those 3 graphs if you want. We need at least 4 inches of concrete above our sensor that is not impeded with anything other than the concrete. So you couldn't put a piece of rebar directly over the sensor, but rebar could be 4 inches above it, or the sensor could be between rebar. You can attach the sensor to rebar. You can drop the sensor on the ground, and you can build up from that. You can elevate the sensor in the middle of the structure, whatever someone wants to be more comfortable with. It just has to be 4 inches from the surface, and usually about 2 inches from an edge of form, just to get good coverage all the way around. I will mention that the sensors are not good use in overlays on pavement, because overlays tend to be 2 to 4 inches or 2 to 3 inches thick. They're relatively thin, and we're always worried about the sensor over time breaking through, that structure. So we do sell for both lab work and for things like overlays, a cylinder sensor kit, where the sensor actually fits inside of a 6 by 12 inch cylinder mold. So it comes already with the sensor in the bottom of that mold with the cable coming out. You can hang a data logger on the side of that. It has a handle to move it around, and all the operator has to do is put about 6 inches of concrete into the cylinder, so fill up that cylinder halfway, and then put it on the shelf, leave it by the structure. It's an interesting way to emulate what's going on with an overlay. So if you're doing an overlay project, that could just be done right in the field, and the cylinder put off to the side. Has a cap on it to maintain the moisture, or it can be taken to the lab or used in the lab when you want to validate the sensor against cylinder breaks or beam breaks without having to put it into a structure. So between those two, the sensors and the cylinder sensor kit pretty much covers anything that somebody would like to do with our sensors for both trial testing and that. I will put a little plug in that the product is in stock. We ship within 24 hours, so readily available. We sell them in individual single sensors and data loggers, and we sell them in kits that vary with the number of data loggers and sensors. We have 3 different kits, which are very convenient to move out. The data logger is totally sealed. It can work underwater. We don't recommend putting it underwater. It has a battery in it that lasts 28 days, and it's wirelessly recharged in a cradle, so you never have to open up anything or plug holes, just drop it in. The sensor plugs into it very nicely, twists off, pretty convenient to use. Data logger is used many times, and the sensor, of course, is a one-time use.
So Joe, our last question here is there any type of concrete these sensors wouldn't work in, like lightweight or flowable fill? And does the orientation of the sensor in the structure matter?
We are recommending to put the sensor horizontally. You theoretically can do it vertically, but we've had some pull away or shrinkage when the concrete cures and pull away from the surface of the sensor. And if that happens, the sensor stops reading. So we'd like to see it horizontal in most applications. If you can mount it vertically, you just have to make sure, usually in a wall where you don't have a large structure, there's usually less concern about shrinkage in a thinner structure, and that's where vertical is good. The first part of that question, Sue, again was
About the different types of concrete.
yeah.
Is there a type of concrete it would not
Yeah.
work?
Yeah, that's so we've been working with we started with horizontal, the standard pour. We like to talk about concrete and what the 28-day strength is. So concrete, our sensor is pretty agnostic to the type of aggregate, the type of mixed design within a band range. So and it's usually based on the amount of cement, the type of cement. So we have models that work for between 2,000 psi to about 7,000 psi, 7 to 12, and then 12 to 20. So UHPC, we have a model for fast curing patchwork. We have that model, and then for normal horizontal vertical work, flooring and pavement and bridge work. That's kind of the middle. We are just started working with RCC and FDR types of applications where you have a little bit of cement ground in, mixed in with water into the ground and then rolled compressed concrete. And just started developing a model for that. And those readings come in much, much lower than normal pavement that has a lot of cement in the concrete. So there's probably isn't an application that we haven't found that our sensor doesn't work in. It is important to be able to make sure that our modeling and our mathematics work for that type. And we have all sorts of programs set up to work with new designs of concrete, cement, or other applications where we can get our sensor to work with, and be happy to talk about those programs.
Great. Well, Steve, I just want to extend a huge thank you for you joining us today and having a conversation with Joe. It was super enlightening. Learned a lot about you and a lot about all the great work you've done in the industry.
Thank you very much. I want to add to Joe that our company has used them in early open full depth repairs, and it's amazing how fast you see everything come up. And when you're waiting out there with a zone out there that they want to charge you $3,000 to $5,000 for the first minute that you're not open, you need that information in a timely manner.
Yeah.
So
That's real money, real money.
they work. Yeah, that's real money there. So they do work phenomenally, and they're backed up by all the beam breaks that we did just to verify. So anyway, great product. Thanks for having me on. It was a lot of fun.
Thanks, Steve. It's great seeing you again. All right.
Yep.
Talk to you all
Great.
soon.
Thank
Thanks.
you
We'll
all.
see you
And
next month.
thank you for all the attendees and your time and participation. And we'll see you guys next month. So thanks. Bye-bye.
Bye.